Next, we move to moment in 3D. Moment in 3D can be calculated using scalar 2D approach, but it can be difficult and time consuming. Okay, so we can use the method of 2D to calculate the moment for cases of 3D like this one, but it is difficult and time consuming because like this one, you look you look at this one. If we resolve the f into the axis of fx, fy, and fz, it'd be taking much time to solve the moment. So simply we can use instead of 2D formulation, we can use the approach of that we call it as a vector cross product. This is a mathematical approach. So in a vector cross product, we can just use the one operation to find the m naught, which is m naught, which is moment, is equal to r cross f. R cross f. Here r is the position vector from point O to any point on the line of action of f. Cross product is a kind of method to multiply vector with vector. Recall that before this we learned about dot product. So actually there are two methods to do a multiplication between vector and vector. The first one we already learned about the dot products. Okay, so let's say we have a system like this, and we have a radius here and then the force. So the radius is in a vector form and the force in a vector form. So if we want to multiply these two vectors, so we can do method of dot product. So this is just a shadow of the to show that this line is not lies on this plane, but it is lying within the x, y, and z axis. Okay, so before this you do the dot product, so the answer is in a scale form. So different with the cross product, if we do the cross product of between two vectors of r and f, the answer must be in a vector form. This is the difference between dot product and cross product. Okay, so the operation for dot product is like this. R dot f is equal to the vector for r dot the vector of f. So this is simply we multiply a component of I with I, component j with j, and component k with k. So the answer will be in a scalar form, but different with the cross product. So you need to do the metric operation like this. So this is the ijk. The ijk for the first line is for the vector of r, and the second line is for the vector of f. And then from this matrix you do this step. Okay, the first step is to find the component for I. When you do the component of I, you need to eliminate this line and do the cross multiplication like this. B multiplied with f and E multiplied with C. So B multiplied with f minus C multiplied with C. Okay, that for I component. And then for J component, the formula you need to remember, there's a negative here for J. For I and K is positive. So if you want to If you want the theoretical explanation, you can do your own read how they get this formula. Okay, so for J, eliminate this line that related to the J component. So, and then what's left, you do the cross multiplication. A multiply with F, C multiply with D. So AF minus CD. Okay, same goes to K component. Eliminate the line that relate to K, and then do the cross multiplication. A multiply with E, AE, plus B multiply with D. Okay, this one is plus. So sorry, it's a mistake here. This is actually also a minus. So all the operation is minus. This is not plus. Okay, so correct this one. Okay, in the end, so your R cross F will be equal to this one, component of I minus component of J plus component of K. So this is in the form of a vector Cartesian. So cross product, the answer will be in a vector form, and dot product, the answer will be in a scalar form. Okay, there's the difference between dot product and cross product, but both is a method for multiplication of two vectors. In this case, a vector R and vector F. Okay, this is the some kind of a principle for dot product and cross product. What's the difference? For cross product, for dot product, when we do the operation of dot product between A and B, so it is equal to AB cos theta. But for cross product, when you do the cross product between vector A and B, it will produce a new vector here, which is C. C is equal to AB sine theta multiply with unit vector of C. Okay, now let's do some example here. If we have a traffic light system like this, okay, so this is the traffic light. This is directly the load or the force. Okay, this is the force here, and then we need to find the line of action. Still remember the line of action and the F. If we multiply the line of action and the F, is will equal to the moment. Okay. First we read the question here. The pole spot 100 Newton or 10 kilogram traffic light. So this traffic light is 10 kilogram. Okay, find using Cartesian vector, determine the moment of the weight of the traffic light about the base of the pole at A. About this point, what is the moment of this system? Okay. Okay, this is our F. So our line of action, you can take the shortest distance between the point A with the force. Okay, so which means that between A to this point. Okay. The step to solve this question, first is find a position vector of a traffic light, and then using the Cartesian vector notation, determine the force that the traffic light acted on the pole. Okay, the position vector means the R lah. Okay, the R is the line of action of this moment. Okay, this one. Okay, this is the R. Okay, I draw it for you. Okay, first, if we want to find the moment, it is actually equal to M equal to R cross F. This time we don't do the multiplication using the product, but we use the cross product because we want to find the value in a vector form. Okay, so first you might need to find what is the vector form of R. So like before this, this same method when you do the vector position method, so we want to find the R, so you need to know coordinate of A and coordinate of B. Coordinate of A is simply 0, 0, 0 because it is in origin. Okay, so your task is to find the coordinate for B. Okay, to find the coordinate of B, you need to find the coordinate for Rx. What is the coordinate here for Rx? What is the coordinate for Y? Okay, and then it's meet here, the point, and going up to define the coordinate of B, which is Rz. Okay. So Rx is actually, you take this length 3.6 meter, but you resolve to the axis of x. The way you resolve is by doing this: Rx over 3.6, Rx here over 3.6 is actually sine 30. This one is 30, this one is also 30. So when you have the value here, your angle is here, so here should be sine 30. Okay, so Rx over 3.6 equal to sine 30. So which means that Rx is equal to 3.6 sine 30. Same goes to Ry. If you want to find the Ry using this value 3.6, so 3.6 for Ry, this means that 3.6 cos 30, or you can write like this: Ry over 3.6 is equal to cos 30. Okay, which means that Ry is equal to 3.6 cos 30. Okay, that is the coordinate for x, Rx and Ry. Rz is simply the length from 0 to 5.4 meter, okay, to meet up at point B here. So your coordinate of B is equal to 3.6 sine 30 for x-axis, 3.6 cos 30 y-axis, and 5.4 for z. Okay, so this all in a meter. After you have these two coordinates, to find the RAB, recall that to find the radius, the length of radius, you need to subtract the coordinate of a tip B. The coordinate of a tip is B. This is a tip B, and the A is a tail. Okay, subtract with the coordinate of tail A. So this coordinate of B subtract with a tail, coordinate of tail of A is 0, 0, 0, and then simply subtract the I component, this one, with the I component of B with the I component of A, J component of B with J component of A, and so forth. So this equal to this one, 3.6 sine 30 minus 0 for I, 3.6 cos 30 minus 0 for J, 5.4 minus 0 for K. And you will get the answer of the AB in a vector form is like this: 1.8I plus 3.12J plus 5.K, 5.4K, and the unit in meter. Okay. So that was the vector form for RAB. The vector form for F, the magnitude for is 100. So this force is simply directly a load, so there is no cable or truss, so you don't need to do to find the unit vector to change the F into the Cartesian vector, but simply just because it is lies on the x-axis, so the component of this force in a Cartesian vector form is only in a k component. So because it is downward, so the direction is negative. So value of F in a Cartesian vector is equal to negative 100k. Okay, in the component of x and y there is no value there, so it is 0. Okay, so after you get two vector of RAB and F, so if you want to find the moment, you can do the operation of cross product between R and F. So to perform the cross product of R and F, you need to do this operation that I just explained using the matrix. So the first line is the vector for R and the second line is vector for F, and then do this step. Okay, please do your own for this one, and please find the answer. First eliminate, to find the I component, eliminate this line, and then do the cross multiplication and subtract between the multiplication. Okay, so in the end you will get the answer in I component, which is negative 312, and J component, which is 180. K component there is no value because when you multiply 0, this one is multiply with 0, this one is also multiply with 0, the answer is 0, so there is no value here. So in the end, the answer is negative 312 I plus 180 J Newton meter. So this is the moment in the form of Cartesian vector. Another question, you are given a situation like this. This is your R and this is your F. So the question asks you to find the moment of the system. So the moment is using the cross product operation, R cross with F. So you need to find the vector system of the R and the vector for the F. So this time the F is not simply directly the load attached to the R, but it has a string or cable here. So there's a work that need to be done before you want to perform the cross product operation, which first you need to find the Cartesian vector of the F. So if we recall how to find the F, the Cartesian, the force in the Cartesian vector form when it is involving the cable, the force attached to the cable. So if you want to find the force in the Cartesian vector form, if you still remember, either you use this method or the position vector method. Cartesian vector, this method, if the information of angle is available, but if it is given the information of for this question, the information given is only the coordinate system. So if you want to find the force in the Cartesian vector form for this cable, you need to use the position vector method. Okay, first find the vector position of R, and then you will get the Cartesian vector form of R, and then find the unit vector of R by dividing the vector with the magnitude of R. And then after you get the unit vector, simply directly multiply with the force, and you will get the force here in the form of Cartesian vector form. Okay, after you get this force in the Cartesian vector form, and then these are in the Cartesian vector form, so you can perform the operation of cross product to find the moment of this system. Okay, so like this one. Okay, so please do this on your own and make sure you will get the same answer in this slide. Okay,